All right, so welcome to McMaster Engineering. My name is Dr. Todd Hoare. I'm an assistant professor in the Department of Chemical Engineering. I'm also cross-appointed to the School of Biomedical Engineering. We do a range of things in biomedical engineering, ranging from imaging, so sort of the MRI kind of stuff that you might have seen in hospitals, all the way down to biosensors, prosthetic limbs, drug delivery, growing new tissues using materials. So it's a range of activities that we do. But my home department is chemical engineering, so I'll actually be talking a little bit more about what chemical engineers do. So chemical engineering is essentially processes and large-scale processing systems. So some people in chemical engineering never touch a single chemical in their whole lives. They spend their time in front of a computer trying to figure out how to use mathematical models to make processes run more smoothly. There's a lot of new stuff that chemical engineers do, things like physical processes. So what you see here is actually a gigantic membrane water filtration unit. So Hamilton is about to spend $700 million installing things very similar to this in our wastewater treatment plant to take the water from Hamilton Harbor, Lake Ontario, and bring it in so it's safe for us to drink. Biological processes. So this can be things like soil remediation, so if there's some sort of contaminant in the soil. Also things like wastewater treatment as well, or the water byproducts from plants. And also just to control processes in general. So for example, if I need a particular flow rate out, I have all these flow rates going in, how do I control the valves? How do I tune the different parameters of the system to make this operate the best possible way? So all these are aspects of chemical engineering. Okay, so bioengineering in general is the application of the principles of biology to develop materials, products, and devices to benefit society and specifically your health. So this is obviously medical. Also be things like pharmaceuticals, environmental processes, also fuels, so biofuels. You've probably heard a lot about people are now being paid to grow corn, and instead of having that corn eaten, they're fermenting that to create ethanol. So bioengineering encompasses all these things. So most of what I do is on the medical side. That's what I'm going to talk about. So bioengineering, the goals really are to understand the whole process, and as chemical engineers we're used to doing this, and understand how living organisms interact and respond to their environments. We also need to understand how biological functions and our engineered products or engineered processes work together. So these are things that you can learn, but we also have the chemical engineering, bioengineering program here at McMaster, which will let you actually get a good basis in biology at the same time you're doing a chemical engineering degree. So ultimately what we're trying to do is make engineered products. So to improve healthcare, clean energy, excess CO2, obviously concerns with that, clean up the environment, even things like bioterrorism. So that's all I wanted to talk about today. So just in summary, a lot of people have called the 2000s the biological century. And it's really just begun. And there's a lot of really interesting work going on here at McMaster in different bioengineering fields and also within chemical engineering, manipulating biology and understanding processes in terms of engineering processes and biological processes to solve medical, environmental, security problems. And chemical engineers are playing a key role in that. So thanks for your attention. Hope you enjoyed the day. And if you have any questions, please let me know.